Let's see. Change the gasket in this thing. Let's see what their average is. 1, L2. Don't forget to do the both lists. Frequencies, very important, very important. All right. We got an average of 94. Call the papers. Traumatic brain injury. Acute. Traumatic brain injury lowers IQ. Call the papers, yes? No. Why? It's lower. Prove to me it's not significantly lower. Or prove to me it is significantly lower, or I prove to you. Maybe I'll prove to you, you prove to me. You have a vote that it's not, so you prove to me that it's not. Di, please, go ahead. You're working on it. Good, you're working on it. There's one more number that can help you answer that question, isn't there? Potentially?
Yes, 9.29.
Yes! This guy, you have to use him too, right?
Yeah.
You can't just go 94. Well, 94 is lower than 100. Boom. Yes, but it's got a plus or minus of 9 points around that 94. That data's pretty bell-shaped, isn't it? I love when that happens. I don't know why it happens, it just does. Why is IQ bell-shaped? Hell if I know. But it is. Even traumatic injury, roughly bell-shaped. We can measure the skew if you wanted to. I don't think you want to. You didn't want to at 243. I can't imagine all of a sudden you woke up this morning and wanted to now. But the idea is, when you have a 9, it becomes a little more cloudy, doesn't it? Because now you've got, if I was like, that's like a 1, I would have no real doubt. But it's not, it's 9. So the problem is okay, we now have to test this thing. So let's have my theory that maybe it is lower, because I think it is. Because I see that shift, and the big thing that I can't help but think about is this. We haven't used that yet. We haven't used him yet, right? Austin brought this up about 20 minutes ago. We haven't used that 61 at all, right? We haven't even touched the sample size. We're looking strictly at the descriptive statistics of the sample. So we have this beautiful sample result that has an X bar of about 94 and has an S of about 9.3. And these are all IQ percentage points. We need some way of turning that into an inferential. This is purely descriptive. I need to make it inferential. I need to make it inferential. Why do I need to do that? Why do I need, this is actually an interesting question. We don't ask it enough in this course. I'm going to start asking it right now. Why do we need to make it inferential? Why do you got to tie a sample size into it? Good. The sample size changes things in what way?
Changes the size of that standard.
Yes. Can I change one of those words to the word error? It changes the standard deviation into what's, you might remember this, you might not. It's called a standard error. And a standard error allows you to take a sample, slap a margin of error on it, not a sample standard deviation. This sample standard deviation only applies to this sample. I want to apply this bad boy to all the possible values in the population and give it bounds. Or in this case, one bound. Your question died, which we'll get to. Okay? So what I want to do, let's come over to the board real quick. We'll work on this. We'll start it now. Might finish by the break. We'll see. What I want to do is, I want this, don't I? Maybe. I want it. Maybe you don't want it right now. I think you might actually talk about it. But what do I want to be here? 0. Or in this case, what else can we put there instead? That 0 would be exactly correct. I'm going to put 0 there because we always want 0 there. What's the contextual value that we're going to put here? We're comparing it to IQ, correct? So you have to go back into the problem and be like, okay, I know that 0 is the standardized value. Thank you, Danielle, for that. So how about, what's the contextual value? Well, that's 100 IQ points, correct? That's 100 IQ points. Thank you. And then again, this will come back to Veronica's question. We'll come back to Di's question as well. So 100 IQ points. So if you will, this is the IQ scale in green, and the standardized scale up here in black will be what we're actually have to work with mathematically. Now what's nice about this is, we know what the contextual value of our test statistic is, don't we? We got it right there, 94 points. And we know it's down here. That's our X bar. The problem is, what? Of course. How far down did it go? Right? How far down did that go? It went left. Obviously, it's less than 100. How far down did it go? So, in other words, it's got a value up here on the horizontal axis, and that right there is going to have an area associated with it. But in order to answer the question, how far down did it go, we have to know how big that area is. And in order to know how big that area is, we have to be able to transfer this back to this. And that's where we're going to start right now. But first things first. First things first. Grab a template. If you don't already have one. Because we're going to, good, it's right here in front of me. Step one. What variable are we testing? Oh, we've changed.